What if the world we see, touch, and feel is just the surface of something far deeper? In this 5-part series, we will explore the mysteries of reality, what it is, its layers, and how different dimensions could shape our understanding of the universe. Welcome to Part 1, What is Reality? This episode aims to uncover the basic concept of reality and delve into how humans perceive it. Reality has intrigued humanity for millennia. At its core, reality refers to everything that exists, whether observable or not. Philosophically, reality can be seen through the lens of theories, such as those proposed by Plato. Plato's theory of forms suggests that the physical world we interact with is merely a shadow of a true reality that lies in the realm of ideas. According to this theory, what we perceive with our senses is just a fraction of these eternal, unchangeable forms. In contrast, scientific perspectives on reality are grounded in empirical evidence and laws of nature. Modern physics strives to understand the universe through the interaction of matter, energy, and time. From the smallest particles governed by quantum mechanics to the vast expanse of space described by general relativity, science paints a detailed picture of reality through rigorous experimentation and observation. Despite these rich frameworks, human perception of reality is often limited. We experience the world primarily through our 5 senses: sight, hearing, touch, taste, and smell. These senses offer a direct line to our environment. Yet they also impose boundaries on our comprehension. For instance, electromagnetic waves beyond the visible spectrum remain unseen, and phenomena like ultraviolet light or ultrasonic sound are outside our sensory reach. Our perception is further molded by brain processes that interpret sensory data, crafting a personal narrative of reality. But is there more beyond this sensory veil? Many thinkers propose that our biological constraints limit the richness and full spectrum of reality. Technologies like microscopes, telescopes, and MRI machines have started to unveil realms of existence previously unimaginable, hinting at the vastness of what we might be missing. In the quest to understand reality, both ancient philosophy and cutting-edge science converge on the idea that what we perceive is just the tip of the iceberg. The deeper truth might be concealed behind layers of complexity, awaiting discovery with ever-advancing methods and theories. As we embark on this journey, the next sections will dive deeper into these realms, peeling back the layers of reality to uncover new dimensions and ideas. As this episode draws to a close, it becomes clear that reality is a complex tapestry, woven from both scientific exploration and philosophical inquiry. The journey ahead promises even more intriguing revelations as we explore the deeper layers and boundaries of existence. Stay tuned as we continue to unravel the fabric of the universe in the upcoming episodes. In Part 1, we delved into the fundamental question of what is reality, and unpacked concepts like perception, consciousness, and the multiverse. But what if our experiences are not real in the traditional sense? What if our reality is an illusion, or worse, a simulation? One of the most intriguing and controversial ideas today is the simulation hypothesis. This theory, popularized by thinkers like Nick Bostrom, suggests that our entire universe could be an advanced computer simulation. While it might sound like science fiction, some argue we already possess the technology to create simulations indistinguishable from reality. Consider the evolution of video games. From rudimentary beginnings to immersive VR and AR environments that almost feel real. Could a civilization far more advanced than ours have created a simulation so complex that we are entirely unaware of it? Could we be living in such a simulation? Moving from the hypothetical to the scientific, we encounter quantum mechanics. Quantum physics presents one of the strangest views of reality. On the subatomic level, particles behave in ways that challenge our conventional understanding, illustrated vividly by the observer effect, where merely observing a quantum system changes its state. This provokes the question, does reality exist independently of observation, or do we create it just by perceiving it? Some speculate that reality is more fluid than we think, suggesting that our perception plays a significant role in shaping it. Lastly, let's examine modern technology. Virtual and augmented reality are pushing the boundaries of how we define real. Virtual reality can transport us to entirely new worlds, offering experiences that feel astonishingly lifelike. Augmented reality overlays digital information onto the physical world, effectively blurring the lines between the digital and the tangible. As these technologies improve, they challenge our understanding of reality itself. If we can create digital environments that feel every bit as real as our physical surroundings, how can we be certain that our own reality isn't similarly constructed? These technologies serve as small-scale simulations, hinting at a future where digital experiences could become indistinguishable from physical ones. As we explore these fascinating theories and technologies, we begin to question the very foundation of our existence. Whether through the lens of the simulation hypothesis, the enigmatic behaviors of quantum mechanics, or the innovations in VR and AR, we are pushed to reconsider what real truly means. In this journey, we may discover that our reality is not as concrete as we once believed, opening up possibilities that are as exhilarating as they are unsettling. Previously in our exploration of reality, we delved into the realms of virtual reality and dreams, probing how the observer shapes our world. As we open this next chapter, we turn our gaze to the vast, intricate tapestry woven by time and space, challenging the very foundations of our understanding. Could it be that time and space are not as fixed as they appear? By unlocking these mysteries, we may inch closer to comprehending the true fabric of reality. Time, as we perceive it, unfolds in a linear fashion, past, present, and future flowing sequentially. But not all cultures subscribe to this linearity. Some envision time as cyclical, a never-ending loop that changes how they experience existence. Stepping into the realm of physics, we encounter Einstein's theory of relativity, which redefined time as a dimension, intertwined with the three spatial dimensions to form the fabric of space-time. Space-time merges the familiar dimensions of length, width, and height with time, revealing a universe where gravity warps this fabric. This phenomenon, known as time dilation, is vividly illustrated by black holes. Near their intense gravitational fields, time stretches and slows. These cosmic monsters provide a glimpse into the astonishing effects gravity exerts on time, hinting at the universe's hidden depths. The notion that time is an illusion opens a Pandora's box of possibilities. According to the block universe theory, every moment exists simultaneously, suggesting that time is less a flowing river and more a static landscape. This concept teases the tantalizing idea of time travel. If time is merely another dimension, could we one day learn to navigate it as we do physical space? Our perception of time is notably subjective. Moments charged with excitement fly by, while drudgery seems endless. This psychological phenomenon influences not just humans but animals too, each experiencing time's passage uniquely. By exploring these perceptions, we uncover another layer in the complex relationship between time, consciousness, and reality. Time travel isn't just a staple of science fiction, it has roots in scientific theory. Einstein's relativity suggests possibilities, and concepts like wormholes offer potential shortcuts through time. Yet such travel raises perplexing paradoxes, such as the infamous grandfather paradox, challenging our understanding and inviting further inquiry into the mechanics of time. As we conclude this journey through time and space, we're left to ponder. If these dimensions can bend and twist, if they allow for travel within them, what does that mean for the reality we inhabit? Join us next time as we delve deeper into this enigma, further unraveling the threads that weave the grand tapestry of our existence. Welcome back to What Is It? The series where we explore the deepest layers of reality. So far, we've talked about the fabric of reality, including time, space, and the mysterious nature of consciousness. But what about the physical stuff, the tangible world around us? Today, we're diving into two fundamental concepts that define everything in our universe: energy and matter. Together, they create the very foundation of reality as we know it. Energy. It's everywhere, yet we can't see it. From the tiniest particle to the most massive galaxy, energy powers everything. But what is it, really? Energy is defined as the ability to do work, to make things happen. It exists in many forms. Kinetic energy, which is the energy of motion. Potential energy, stored in objects waiting to be released. Thermal energy, which is heat. And even electrical energy, which powers our modern world. Energy is the invisible force that fuels the stars, drives the planets, and sustains life on Earth. In the cosmic sense, energy is what lights up the universe, whether it's the radiant energy from our sun or the immense energy released when a star dies. One of the most fascinating aspects of energy is its conservation. The first law of thermodynamics tells us that energy cannot be created or destroyed. It only changes form. So the energy that once powered ancient stars is still with us, just in different forms. If energy is the invisible force of the universe, matter is its tangible counterpart. The stuff that makes up everything we see, touch, and feel. But what exactly is matter? Matter is composed of atoms, the building blocks of all things. From the smallest grain of sand to the largest planets, matter exists in different forms: solids, liquids, gases, and plasma. When you break it down, atoms are mostly empty space. But the interactions between these atoms, the forces holding them together, are what create the solidity of matter. From the furniture in your home to the stars in the sky, matter is what forms the structure of the universe. So as we ponder the vastness of the cosmos, let us also marvel at these fundamental components, energy and matter, that make our existence possible. Together they weave the intricate tapestry of reality. The enigmatic relationship between matter and energy forms the very crux of the universe. This interconnectedness is beautifully illustrated by processes such as nuclear fusion and fission, where matter transforms into vast amounts of energy. Deep within stars, hydrogen atoms fuse to create helium, releasing energy that radiates across the cosmos, lighting up worlds and fostering life. Nuclear fission, on the other hand, involves the splitting of heavy elements like uranium, unleashing energy that powers our civilizations. Both processes underscore the profound truth that matter holds immense potential energy within its atomic bonds, ready to be released under the right conditions. Quantum mechanics delves deeper into matter, showing that energy and matter are inextricably linked on the subatomic level. Here, particles such as electrons and photons exhibit wave-particle duality, oscillating between being waves of energy and discrete particles. This duality means electrons, which were once thought to neatly orbit atomic nuclei, actually exist as clouds of probabilistic locations until determined by observation or measurement. This fluidity reveals that matter isn't as solid as previously believed, consisting instead of dynamic interactions with surrounding energy fields. Quantum field theory further elaborates on this intimate dance by suggesting that all particles of matter are excitations in underlying fields that permeate space. This perception reveals that even empty space brims with fluctuating energy and potential matter. Thus, energy is not merely a force, but the very bedrock from which all matter arises, demonstrating once again the deep-seated unity between energy and matter. These insights shape our understanding of reality, redefining matter as a manifestation of fundamental energy fields. The ramifications of matter and energy's interplay extend to the fate of the universe itself. Observational cosmology shows galaxies drifting apart, propelled by a mysterious force named dark energy. This unseen force pervades the universe, accelerating its expansion and counteracting gravitational pull. Concurrently, dark matter, a type of matter yet to be directly observed, exerts its gravitational influence, holding galaxies together while invisible to conventional detection methods. The delicate balance between dark energy and dark matter orchestrates the universe's grand expansion. These cosmic forces illuminate the universe's destiny. Will dark energy dominate, leading to an ever-accelerating expansion into cold, empty space? Or will the gravitational forces of matter, especially dark matter, eventually halt and reverse this expansion, resulting in a cosmic collapse? The ongoing dance between energy and matter, observed from subatomic particles to galactic scales, not only shapes the current cosmos, but also holds the key to understanding its ultimate fate. In this ever-evolving cosmic ballet, matter and energy's intricate choreography continues to captivate our quest for knowledge. As we conclude this 5-part mini-series on the intricacies of reality, let us weave together the threads of our journey. We've traversed the nature of reality, delving into the multiverse and the layers that surround our perception in Part 1. The exploration didn't stop there. It led us into thought-provoking realms like the simulation hypothesis and quantum mechanics, pondering the essential role of consciousness in shaping our experience in Part 2. Moving forward, we journeyed through the dimensions of time and space in Part 3, realizing how these elements shape our understanding of existence. Time unfolds like a tapestry, entwined with space, and forms the canvas upon which reality is painted. In Part 4, we stood at the crossroads of energy and matter, acknowledging their profound interconnectedness. The equation E=mc2 became a symbol of our realization that energy and matter are dual expressions of the same underlying fabric of reality. In this final episode, we reinforce the notion that energy and matter are not separate entities, but facets of an indivisible whole. Their interplay creates the observable universe, a stunning display of stars, galaxies, and life itself. This unity prompts us to ponder the role of consciousness in this great tapestry of existence. Is our perception merely a reflection of an independent reality, or does our consciousness actively shape the universe around us? The observer effect in quantum mechanics nudges us to consider this relationship, blurring the boundaries between perception and reality. As we explore reality further, we recognize that it is a dynamic process, perennially evolving through the interactions of energy and matter. Just as time marches forward, so does our understanding of the cosmos. Our experiences are colored by the tides of time and the geometry of space, bringing richness to our exploration of the universe. However, the mystery deepens with dark matter and dark energy, the unseen forces that govern much of what we perceive. These enigmatic components compose a significant portion of the universe's mass, yet remain shrouded in secrecy. Contemplating their role invites us to consider how much of reality lies within the shadows, waiting to be uncovered. In wrapping up this series, we acknowledge the infinite complexity of reality. It invites us to continue our quest for understanding, encouraging an insatiable curiosity about the universe we inhabit. As we close this chapter, we tease future explorations into higher dimensions, the nature of consciousness, and more, promising a journey that never truly ends.